You're back on?
Yeah.
You were planning to be in class this week, weren't you? Oh, you're muted now.
My doctor needs my insurance stuff to sign my return slips and stuff.
Oh, okay. That's what I was thinking, because I thought last week you thought you were going to be back, so. All right. So, does anybody have any questions before we start? All right, so thought we'd start off today. Let's see. I think I'll just run the risk. That thing I'll shut off. So we're doing these cost curves and stuff, and so this is a really important as we get into the upcoming chapters. So we're going to be talking about companies and how they maximize profits ultimately as we get into chapters 22, 23, 24. And these cost curves that we're doing apply to all companies. So all companies kind of have these similar concepts going on in terms of how they evaluate the cost of doing business is what we're focusing in on. And so yesterday we looked at profits and different ways to organize profits. And was it okay to earn zero profits in economics? Yes. Did I hear a no? No. It's okay. We want more. But I think that's the first time that you guys, would have thought of something like that, short of you being in another economics class, because we're kind of looking at the whole environment, right? We're not just looking at one company. Every company wants to maximize profits, which means let's make as much money as we can, right? Short of not breaking the law and maybe being respectful to our employees, right? That kind of stuff can go person to person, but the main objective is to maximize profits. But then what we see is, if you remember back, I think it probably was the first day of class, I said, well, it is not Adam Smith, I was repeating Adam Smith, it is not the benevolence of the butcher, the brewer, the baker from which we expect our dinner, but from their regard to their own self-interest. And then I said, well, what keeps the butcher from raising the price of meat from $10 to $20? And what was the answer? Competition, yeah. The baker could come in and start processing meat as well. And so if the butcher does raise the price to $20, somebody else comes in and says, well, that's an abnormal profit. What we learned yesterday is economic profit above zero, basically abnormally high profits. Easy money, if you want to think of it that way. And so the baker enters the market and says, well, I can do it for $18. And then the butcher says, oh, I better drop to 17. And then the baker does this, right? And so competition is what preserves a fair profit or a normal profit as we characterized it yesterday. Okay, so along the way then, since economics is about decision making, we need to break down costs that vary with production and costs that don't vary with production. And so that's about where we left off yesterday. And Nate had given you some of those definitions as well. So here, our total cost can be broke down into the costs that vary with production plus the costs that don't vary with production. Fixed cost and variable cost. Give me an example. What was a fixed cost for our grocery store? Just one of them. Rent. That's kind of the easy one to kind of remember as a fixed cost. The landlord doesn't care if you do 500 beeps or 5,000 beeps. You owe me $2,500 every month in rent, right? So that cost of production stays fixed, independent of what the number of beeps or the number of sales that are sold. And then there's other costs then that vary according to production. So what was a variable cost with our grocery store? Goods. The goods. The goods themselves are probably the easy one, right? So I'm going to incur a cost as we go. So we have variable costs and fixed costs, and that gives us our grand total. Okay, so that's kind of where we left off with. And so the first thing I want to start you off with today is looking at the average total cost. Average total cost. That's kind of a nice thing to look at because we always have price on price per unit, right? When I go to Walmart and look at this thing, it's $18.65 for this insulated mug. It's priced per unit. So the company who sold these, which is Contigo, by the way, these are fabulous. This is the spill-proof, drip-proof, so I can throw it in my computer bag and not have to worry about it. So it's worth all the $18 for me anyway, and it keeps it pretty warm too. So the Contigo company might like to know what is their cost on average per unit. I'm selling them for $18.65, and so that would allow me to think kind of in average profit per unit, ultimately, is where I'm going with this. So if they make 100,000 of these mugs, how do they calculate the average total cost? Their total cost might have been $2 million or something, right? The total cost of making 100,000 mugs was $2 million. How would they calculate the average cost per unit? What would they need to do with the $2 million in total cost? Yeah?
You can just divide the 2 million by 100,000.
Yeah, you just divide it by the quantity, right? Real easy peasy. So you made 100,000 of them, you divide by 100,000. So in general, what we do is divide by the quantity. So this is the quantity produced, and by doing that, 2 million divided by 100,000, we could come up with a number, right? The average total cost. So this right here is the average total cost. And I know you had some of that written out from last time, so I'm going to probably stick mostly with abbreviations here. Average total cost. Now, I intentionally wrote this as an equation this time because we all know what you do to the left-hand side of the equal sign, what do you got to do over here? The same thing. You got to do something over here. And so you can do that a couple different ways. You can just divide the whole thing by Q, but it's a little more convenient with this case is to spread that Q across both things here. And now we've maintained our equation. And it also lets us know another convenient way to think about these costs and how they're related to each other. We can also look at the average variable cost, and it then must be equal to the sum of the average fixed costs. Average total cost, rather, is equal to the sum of the average variable and average fixed costs. So this is one of my favorite things. If you guys try to commit that to memory, and the reason is you can answer a whole bunch of test questions by thinking about this expression. And I know it looks like a lot when you first look at it, but if I unpack it for you and you know some of the other bits and pieces, it's not that hard, right? Total cost has variable cost and fixed cost. Divide the whole sucker by Q tells us that the averages are related this way. And so in a problem, you might say, they might ask you, well, what's the equation for average fixed cost? Boom, you've got it, right? So there's one formula. There's another formula, the average variable cost. There's another formula, the average total cost. There's another formula, the relationship of the totals, and then the relationship of the averages. So there's like 5 different things kind of wrapped up into one expression. So this is a good one to try to commit to memory. So let's just put memorize that thing. All right, so that's our equation goggles so far. And the next thing I want to do is kind of put our equation goggles on and view the math here with some equations. Let's start with the total fixed cost. If I was to measure the total fixed cost and graph it with quantity being on the horizontal axis, what would it look like? So you've got quantity getting bigger along the horizontal axis. What would the total fixed cost curve, graph look like?
Isn't it just a straight line?
Straight line. Yeah, you're doing this, horizontal or vertical, or it could be downward sloping, upward sloping, so we got all these horizontal, right? So if the total fixed cost is $100 or $100,000 or whatever, if we make 10 units, 20 units, 30 units. It doesn't matter. At 10 units, my fixed cost is still this. It doesn't matter how many beeps there are, right? And so my total fixed cost function, graphically, looks like that. All right, so then, what would the average fixed cost function look like graphically? Now I want to get down to this one. What does the average fixed cost function look like? As we increase quantity, yep.
Same thing again.
And it's Tyler, right?
Yeah.
Okay. Same thing again. No. Kaylin? You're itching there. I saw this, and then you're like, oh, maybe not, maybe not, maybe not. What's that?
Upward sloping?
Upward sloping? No. Which leaves a couple more choices. We're narrowing down the field. It's not flat again, and it's not downward sloping. Jensen?
Is it like a parabola type thing?
What do you mean by that? Like kind of curvy, like we did before with the total revenue?
Yeah.
It's curvy. It's curvy. I'll give you that. But it's not a parabola that looks like an upside down U or anything. So, what is the average fixed cost of producing 1 unit? If I just go to the 1 over here, 1 little unit here, what is my average fixed cost equal to? 100. So now it's the same as what some of you were saying. At 1, that's true. At 1, the average fixed cost is 100 equal to the total fixed cost. We're just dividing that by 1. What is it at 2? What is it at 2?
Isn't it a curve?
Nope, just give me the answer. You guys can shout them out. I'm going to try to nurse this one. What is it at 2? The average fixed cost of production, what is it at 2 units? Averaging it over both units. 50, right? So it's just the total fixed cost of 100 divided by 2 units now gives us 50. So right away, after just 2 units, we are looking like this. What is it with 3 units? 33.33. What is it at 4 units? 25. What is it at 10 units? 110. 10 divided by 10, 10, right? So now we're down to 10, and then 30. Roughly. 3, yeah, around 3, right? 3 and some change. All right, so check it out. What this thing's doing here is that, so let's see, this is at 10, is it's basically going to look like this. average fixed cost. So yes, it's downward sloping, yes, it's curvy, but it's dramatically going down fast after just one unit. So like if you're an airplane producer, do you make 100,000 airplanes a year? No, you make like 5 or something, right? And so your average fixed cost is fairly high if you produce a really expensive thing that you don't make a lot of. But if you're like most of the stuff on the shelves at Walmart, are they making a whole bunch? Yeah. And so average fixed cost can go down fairly quickly. So average fixed cost can diminish fairly quickly as we produce more units. Okay, questions or comments there? All right, so this one turns out to be, I think, important as a building block, but the average variable and average total are much more important for us in kind of decision making. So let's see. Start off with a new one now. For this one, I'm going to kind of spoon feed it to you. So watch me draw this because it can be a little tricky. There's some unique things to it. And then I'm going to backdoor try to tell you about why it looks the way it does. So it's easy to start off with the average total cost curve is a bowl-shaped curve. So a U, so this is the parabola as Jensen was talking about mathematically. And so just draw it on your paper, any sort of U. The important thing is I want you to find the point where it is minimized. So there's some point where it is the smallest point on your paper. And go ahead, and that is the minimum point, right? Big fat dot. Okay. Now this is where it gets a little tricky, so watch me draw this. So the next one, the average variable cost curve, is also bowl-shaped, but the minimum point is somewhere to the left of where you drew this one, so it's somewhere over here. And then there's one other important point. As it bottoms out, it comes up and approaches the average. You see how the vertical distance is doing that? That is the average variable cost curve. So go ahead and try to make that on your paper, try to work that way. Doesn't really matter where you bottom out, but somewhere the minimum point is going to be somewhere to the left of where the total one was. And you can put a big fat dot there. Now, the tougher question. Why does it look the way it does? Especially this part. Why is this vertical distance narrowing as we go up? That's not an easy one to figure out, but you could do it. You have enough information on the board here, actually, to piece it all together. It's a little bit of a puzzle. Why is the vertical distance between average total and average variable shrinking as we move this way along the horizontal axis? This one's definitely worth extra credit point. Let's see if anybody can unpack the puzzle. What's that?
Oh, I see.
Feel free to, you can throw stuff out. Like I said, it's okay to be wrong in this class. Very important. But I want you to be less wrong, which I forgot to talk about, the test on Thursday. It's important to be less wrong on Thursday. While you guys cogitate on that, let's talk about Thursday. I want to make sure I don't forget. So, midterm test is going to be on weeks 1 through 4. So it's not including what we're doing right now on cost curves, right? So it's what we wrapped up with last week. So weeks 1 through 4 on Thursday in class. All of your time with your notes is going to pay off. That's going to be your most important study tool. And then I'm going to, in addition, give you a practice test today that'll come out. And then our economics tutor, JC, is going to hold a review session. So I posted an announcement if you need to rehash these details. JC today at 4 p.m. And this is just an optional review session. And this will allow you to look at the test and kind of ask some questions of JC, and he can try to help you reason through things. I like you to think of the practice test as a head start to your test on Thursday. So I don't help you with it because I'm kind of giving you some pretty good hints on what Thursday's going to look like. And so think of it as a head start, unless there was clarifying questions. Otherwise, JC, our tutor, is there to help you out as well. And so that's today at 4. So even if you have practice, I'd talk to your coach, see if he or she might be cool with you going to this review session. So it's something that would be important. It is optional. So if you can't make it, you can't make it. Did I see a hand up? Yeah.
So is the test open though, or?
No, the test is not open note. So you come in after you've studied. It's a good old-fashioned in-class test that's going to be all short answer. So it's going to be like the examples I go through in class, some of the stuff that we did, and then again you'll have your practice test to give you some more lead on that. Okay, any other questions? All right, back to this thing. Oh, that's right, I had my extra credit pen in hand. Anybody want to take a stab? Why is that vertical distance shrinking as we go this way? Caleb?
Is it because the quantity makes them kind of even out over time?
No. Yes and no, but I would need a little bit more information. Why is the quantity, or why is it evening out, as you say? Because it would basically start to get close together. They'd never cross, by the way. They'd never cross, but they would get infinitely close to each other, if that helps you. What's the relationship of this one and this one together? What's the relationship? I already gave it to you. It's on the board over there. Just have to translate. You got to be able to, it's like if you're in Spanish class, like this is English, here's Spanish. Well, this is English, and now I'm asking you to use your math language.
Because you have to subtract the AFC from the ATC.
Good, yes. So it has to do with this relationship of the average fixed cost. So check this out. The average fixed plus the average variable equals the average total. So the relationship between these two is that if I bring this over to the other side, average total cost minus average fixed cost would equal average variable. So that's the connection. In other words, at a quantity, and I'm not going to relate these quantities to these quantities, so just so that we're not confused. So if we have 100 units right here, the average total cost of producing 100 units, how do I use these graphs? I go head north until I hit the thing that I'm interested in, hang a left, and read off that number. That number is the average cost per unit. Let's just say it's $44. So the average total cost of producing 100 units is $44. Well, what's the average variable cost? Oh, I know how to do that. I go at 100 units, I go up to the average variable cost curve, hang a left, and I read off that number. And again, I'm just making up some numbers here, so let's say that this is 32. So the average variable cost of producing this product is 32. Using those numbers, what's the average fixed? $12, which now is this vertical distance between the two, right? So if I take this vertical distance right here, that is my average fixed cost of $12, 44 minus 12. So in general, we don't draw this graph again for the most part. You might see it on a homework or something, but we'll use this one a lot. And the reason we use this one is that it already has all the information we need. Average total, average variable, average fixed is always this vertical distance. What's happening to the average fixed cost as I evaluate lower quantities? What's happening to the average fixed cost per unit? Is it going up or down? Average fixed cost of producing, let's just say 50.
It's going down.
It's going down. The average fixed cost is going down. Average fixed cost. Okay, how do you know no?
Because it's bigger between the ABC and ATC.
It's still this distance. So here, at 50 units, the average total cost is here, the average fixed or average variable cost is here, and so this is the average fixed cost. It's bigger of producing 50. Why? Because over here, when we cut it in half, I'm not getting my rent spread out over more and more units again, right? Remember I had $2,500 of rent at my grocery store? And it makes a difference if I'm doing 5,000 beeps or 500 beeps. All of a sudden that rent gets pretty expensive when I'm only doing 500 beeps as opposed to 5,000 beeps, right? And so as we have less production, my fixed cost is being spread over fewer and fewer units. And that's causing my average fixed to be bigger. Okay, questions or comments there? All right. So the most important cost curve we haven't even talked about yet, and that is, well, we have talked about it in previous chapters, but not the way we're going to do it now, and that's the marginal cost curve. So marginal cost, the most important one for decision making. Marginal cost is the cost associated with an additional unit of production. The cost associated with an additional unit of production. And that's pretty much the same definition we gave you before. But now we're going to kind of look a little closer here at how that comes about with the cost of production of the company. So marginal cost. How do we calculate it? First of all, putting on our equation goggles, the marginal cost of production is equal to the change in total cost over the change in quantity. The change in total cost over the change in quantity. So remember, we use the little triangle as a shorthand math notation for change. So if you're not careful, look at that. Total cost, what's that formula right there? Without the triangles.
The
Average total cost, right? So all of a sudden we put in those triangles and it changes everything, because now we're looking at incrementally. Suppose my total cost of production was $2 million. Well, what if I produce one more unit? How much does my cost go up by? Does it go up to 2.1 million? Does it go up to $2,005? Does it, what is my extra cost of just squeezing one more unit off the production line? All right, so now, again, I'm going to play a little bit on this math formula here. If I'm doing the change in total cost, let's do the change in total variable cost divided by the change in quantity, plus the change in total fixed cost divided by the change in quantity. So I kind of did what I did over here. I just distributed the little triangle across the formula. And this one turns out to be pretty insightful as well. We can make this a lot more simplified. How can we make this a simpler equation? This is, again, kind of a little bit tougher, but it's insightful. I think it's good to noodle our way through this one. So let me read it to you again. Marginal cost is the change in total variable cost from an additional unit of production plus the change in total fixed cost from an additional unit of production. How can we simplify that? I hear some whispers. Be brave for the Ottawa Braves. I'll give you a hint. It has something to do with this picture a little bit. So hang on my words here. Marginal cost is the change in total variable cost. Give me an example of variable cost with the grocery store. The goods themselves, maybe the cashier, other things, right? Change in total variable cost from more beeps, plus the change in total fixed cost, which was what? Give me an example from grocery store.
Rent.
The rent. The change in the rent from more beeps. Which one has a problem, Tyler? There's no change in the rent. So if I was paying $2,500 before, how much am I paying now? $2,500. $2,500 minus $2,500 equals zippo. There is no change. This one disappears. So this one does not change or vary with Q. So it kind of it does disappear when we are thinking about marginal cost. And so again, this is one to memorize right here. When you think about marginal cost, you can think about total cost going up when you bump up production, but the only costs that are changing are variable costs. So you could also look at variable cost when you look at marginal cost. All right, so this is another little memorize. That's a great one. Okay, so now, what does this thing look like graphically? Well, let's redraw. Let's redraw our average total and average variable. So just like that, we won't put all the details, but you're just redrawing what we did before. You got the two bowl-shaped curves. One's getting closer. Now we know that the difference between the two is the average fixed cost. All right, here's how the marginal cost curve fits in here. It's J-shaped. It's J-shaped, so it's actually going to bottom out before that one. It's J-shaped and cuts through those minimum points. That's the key part, is that it cuts through. That's why I had to draw those big fat dots. Go right through those minimum points. Okay, any questions so far? So, a great question would be, why does it cut through those minimum points, right? So, I want to tell you a story about a student here at Ottawa. And so, that student came to Ottawa during their whole freshman year. So they were a freshman here and ended up at the end of the freshman year getting a 3.0 grade point average. Not too bad. But during that year, picked up some friends that weren't so great with grades, and let's just say. And so started drinking, did a little pot, you know, no big deal, kind of college experience. And sophomore year, fall term, got a 2.0. So their freshman year, they had a 3.0 grade point average, and now sophomore year, fall term, got a 2.0. What's going to happen to their overall GPA? Is it going up or down? Down. Is it going to go down to 2.0? No, because you got the previous year kind of buffering it, right? So let's just say that the GPA went to 2.7. And mom and dad weren't too happy with him. And he's like, okay, I gotta buckle down. And so sophomore year, spring term, did better. Got a 2.7. Spring semester, sophomore year, got a 2.7. What happened to his overall GPA? He was at a 2.7 before, and now he got a 2.7 for his spring semester, sophomore year. Is it gonna go up? It's gonna stay the same. So if you add a 2.7 to an overall 2.7, it can't go up, but it's also not gonna go down. So he improved from term to term, but still not there. And then he's like, okay, junior year, I've got internships I wanna get, I'll party a little bit, but not so much. And so junior year, fall semester, gets a 4.0. Bullets across the board, all A's. What happens to his GPA? It goes up. Does it go up to a 4.0? No, right? Because he's got the 2.7 currently, but it is going to pull it up. But now he's got 2 years worth of grades at the 2.7 level. And so even a 4.0 for one term is just going to have it turn up a little bit. So let's just say it turns up to a 3.1. And then our story can end. Because that relationship of your semester grades versus your cumulative GPA is exactly what's going on with this picture. So as we have product where the cost of an additional unit, let's just say the 20th unit, if I look at 20 units here, the cost of the additional unit that I produced was this amount. Let's just say it's $10. So the 20th, remember when we're using the marginal cost curve, then we have to kind of put on the 20th. If I say well, I better be careful with potential COVID here. The 20th implies what? When I say I'm looking at the 20th unit, what does it imply about your current levels of production? How much were you making already? 19. So it's very important with the first, the second, the third, the fourth. We're talking about one unit. Marginal cost was the cost associated with an additional unit of production. So when I produce this good, let's just say it's shampoo here is our market. So we're a shampoo producer. The 20th bottle of shampoo cost me $10. All 20 bottles of shampoo, on average, cost me $18. So eventually here, this starts to hit the minimum, but as I'm moving this direction, the marginal cost is below the average, so this is your GPA, is below the average, pulling your average down. Eventually you get to a spot, let's just say the 25th unit. The cost of the 25th unit is $17.80. And the average total cost of producing 25 units is $17.85. That was when you had an overall GPA 2.7 and you got a 2.7 for the semester, right? So it stayed the same. And then we get to a point where extra units get kind of costly for reasons we'll get in later. And so if we look at 35 units, the cost of the 35th unit was really expensive. It was, looks like $28. So that extra bottle, the 35th bottle of shampoo, cost me $28, which caused my average to go up, but of course not up to 28 like when I got my 4.0 for the semester, but rather just a little bit. Maybe it came back to 18. Okay, any questions on that? All right. So now, why does it have that shape? There's some details going on. We've been talking about dollars, but now I want to weave in the actual physical relationship of the production process. How does the production process actually work when we think about making something? So when I was 15 years old, I worked at a restaurant. It was kind of a greasy spoon restaurant. Worked for a guy who was an alcoholic. On Saturday morning, he'd always be 3 fingers deep already at about 8 o'clock. Good old Rawl, loved him. And so we made hamburgers. So I want you to visualize this tabletop as my grill at the restaurant. And so as a worker, as one Russ, I was pretty productive. I could do 100 hamburgers working by myself, right? So the physical production process involved me, some ground beef, some buns, some ketchup, some lettuce, tomatoes, a grill, right? So those were the resources that were physically needed for Russ to turn raw ground beef into a finished product of a hamburger, right? So I'm not talking about dollars at all as my main thing. No dollars are involved here, just hamburger production. So assume that I can do 100 currently, and I want to do more, so I add another worker, another Russ. So I add another person, and my question is, with 2 of us working at the grill, would my hamburger production go up from 100 to 200, more than 200, or less than 200 when I add a second person to the production process? What do you think? 200, which means we double, right? I could do 100 by myself, and now it's 200, or is it more than 200 or less than 200? How many people are leaning towards 200? That I double. Add a second Russ, goes to 200. Okay, I see some hands up. Be brave. I just want to get a general feel for you guys out here. How many people say less than 200? Okay, we got lots of less than 200s. Got Zoom going too. How many say more than 200? Just the lone soldier Dawson. Okay. All right, so I got some good news. Everybody's right. Everybody's right under certain additional assumptions. So I'm going to start with Dawson because I'm kind of curious. So I'm giving you guys the confidence that you're right, but I want to know the reasons why you thought so. So Dawson, let's just start with you since you were the lone soldier with going above 200. What were you thinking?
So I was thinking, if you bring another person in, you could find out what you both are, the best at, what you're quickest at. So if yours is making it and actually on the grill, and the other person is putting the buns and then the toppings on, or vice versa, you can do it that way to maximize it.
Okay, good. Does your answer change if Russ is actually, the extra person is a clone? You guys know that cloning's starting to come around, right? So let's just say it was an identical Russ. So we're equally skilled is kind of the point I'm getting at. Does your answer change at all if it's an identical Russ as opposed to, I like the way you told that story, you kind of talk to each other and learn what you're good at, but now Russ and I are having a conversation. It's like, you like that too? I like Kiss. You like fishing? Oh yeah, I guess we're genetically identical twins. So does that change your answer at all?
Probably make it go lower than it. It'd probably be around 200 or right under 200.
Okay, or right under 200. Well, here's the story. Your answer would actually still be the same if there's opportunities for specialization. So I'm kind of went an extra level of detail down from where Dawson, and Dawson gets some extra credit because that's great that you pointed that out, by the way, with the comparative advantage in being different. But you don't even need that. And that would be the normal story, what he told, right? Like, we don't assume identical cloned human beings. But even if you were cloned, you might be able to get more than 200 through what Adam Smith identified as specialization of labor. So now, even if it's identical Russes, you can imagine there being productivity gains by one Russ getting to focus in on the burgers, the patties, and the grill, and the other Russ is setting up all the tabletops, right? With the buns and the lettuce and the tomato and the pickles. So even if they're identical, it's possible that there could be an uptick of production beyond 200 with specialization. Okay, Now, with 200, that's possible too, but let's get back to the less than 200, where that was most of the class, and you guys are right under a certain amount of, this is where I want to hear your additional statement. Does somebody want to venture on? Yeah, Augie?
One thing is, how many burgers could you possibly need to the point where you're wasting product?
Okay, that's a good point. So right now we're going to ignore the demand side. So you're kind of talking about, do I have enough customers or am I going to be wasting it? In this case, all I'm trying to do is make hamburgers, so otherwise you can assume that these aren't going to go to waste because there's somebody there to buy them. But we're kind of trying to ignore that and focus just in on production.
Okay. Production-wise, when you're working with multiple people in a kitchen like that, you just get crammed.
Okay, good.
It's like overlapping.
So yeah, you end up getting crammed. Justice, you want to add on?
Also, you have to make sure that you're cooking the burgers, so you can't like change that time either.
Yeah, okay, so, and what do you mean, expand on that a little bit more. What do you mean, why would I run into problems cooking the burgers if I'm here making burgers?
Well, just like the time that it takes to cook them, you can't like really rush that like with another person. So
What would cause me to have to rush it? Let's assume I'm not rushing it, that I'm cooking the burgers the way they're supposed to be cooked. Because I think you're touching on another constraint that's important, which is part of what Augie was bringing up. What would cause me to want to rush and get them done too soon?
if somebody was rushing, like your other
Maybe.
person.
Tyler?
Like if the other person gets all this stuff laid out and they're just waiting on you to put it there.
Okay. Not what I'm looking for. And this is part of just real world versus economic theory, which can be a little more abstract. So you guys are touching on some good topics, don't get me wrong, Ben.
If you had to make a certain amount.
Okay, and right now we're not making a certain amount, we're seeing how much we can do in a given time. It is in a given time, so I like what Justice was saying. We're saying per hour, per day, whatever, there's some sort of time constraint, but there's a timer, but it's not a pressure cooker like you two were bringing up, like, go, and then the boss is sitting there with a whip, and it's like, McCullough, you better get going, or I crack the whip, right? And then I'm undercooking the burger. So that's reading too much into the story. But you know, real world, that's some real things that could be going on. Jensen, did you want to pass, or you still got
Busy times of the day.
busy times a day? Again, we're not worried about the busy times, but what would cause the problem that I was trying to get to, that I think you guys were close to saying, and it's similar to what Augie was at, is I only have a certain size grill. So if I was trying, if the hamburgers were maxed out, and I'm like, oh, he's still waiting on me, we could still do more, you know, would you pull the hamburgers off early? You know, I think realistically that would be, but what's constraining you is the grill, right? It's the grill that's your constraint. It needs to be a little bit bigger perhaps. And that's exactly what starts to kick on. So what I'm saying is we're gonna assume that I'm fully cooking the burgers the way they're supposed to be prepared, which means I can only do so many because my grill space is limited, right? So we add another person, eventually we'll get to that point where we start hitting some congestion. Where does that happen? It depends on whatever production process we're looking at. But the phenomenon is the same. It's called the law of diminishing marginal product, and it's probably one of the top 3 principles of economics. It's also called the law of diminishing returns. So it goes something like this. As you add more and more russes to the production process, the amount of product that each additional russ contributes eventually declines. The law of diminishing marginal product. The additional product that's being made is going to eventually fall due to congestion issues of not having a big enough grill. So some resource is fixed. All right, so let's write that out. Yes, question? Sam, go ahead.
Yeah, what is it called again?
The law of diminishing marginal product. I'm going to write it on the board. Okay, so a couple things we need to write out here. So total product, which is basically our Q, right, is the total amount of production from a given amount of resources. I have a grill, I have the burger, I have You know, so the grill, labor, the actual raw meat, raw burger. I've got buns, da 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 da. I got all these resources. And so how much can I make? What is the total amount of production, the total production quantity? All right. I don't want to, let me just check really quick because I hate to give out extra stuff that your book doesn't use, but sometimes it's TP for total product, but I'm just gonna stick with Q if the book doesn't use that. I kind of think they don't. Oh, they do use the word output though. That's total product. All right. Yeah, so they use the word total product just like I wrote out here. I don't see the word TP there, but we could think of or output, because you do need to use this interchangeably, right? That's the product we're making is the output from the inputs would be another thing for resources would be inputs. And then just for the heck of it, since we're here, let's just do the total product, TP. Even though at least at a glance, it didn't look like they had that, but they could. All right, well, that's not the important one, at least for econ class. We talk about that one because we really want to get to the marginal product. The marginal product. And so this is the additional output from an additional unit of a resource. So for example, what I just brought you through was and this is a common one we look at, the marginal product of labor or of Russ's. But we'll just call it the MPL, the marginal product of labor. Add another Russ, I get some more hamburgers. All right, so now I hope to kind of tie this all together. Start from left to right. I'm going to make a whole big table again like we've done before. 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe even 10 columns. Are you ready? Here we go. So labor, this is the amount of Russes. So we're going to go 0 through 5. 0 Russes, 1, 2, 3, 4, 5. Quantity of hamburgers. So this is the total product of hamburgers. With 0 Russes, I get 0 hamburgers. I definitely need at least 1 Russ to make hamburgers. When I have my first Russ, I get 100. The second Russ, let's assume, brings us up to 220. So we have what Dawson was talking about with specialization of labor. And so 2 Russes together could get us that. 3 Russes bumps up to 320. 4 Russes, 400. 5 Russes, 460. All right, so then we've got the marginal product of labor, which is what each additional Russ does. So if you want to do a little formula here, it's the change in quantity over the change in the number of Russes. I guess I could have put that down here also. Marginal product of labor equals the change in quantity, the change in output from an additional Russ. Just replicated what I did there. So the marginal product, the additional product that the first Russ brings in is 100 hamburgers. What's the marginal product of the second Russ? 120, good. So that's what gets a little bit weird. Notice that we're giving all the credit, if you want to think of it that way, to the second Russ. But really, it took 2 Russes to do it, right? So we're just looking at the productivity of the second worker. Don't hang your hat on too much that the second Russ is, and that's part of the reason I've over the years converted this to the cloning concept, is that the 2 Russes are equally skilled. So if this Russ would be in the first position rather than the second position, the first Russ would do 102, right? There's no different. We didn't add a more skilled Russ. It's an equally skilled Russ, but it's through specialization that we got this 120. All right, and then the third Russ, we start to see the law of diminishing marginal product kick in here, that the extra Russ gives us 100, and then the fourth Russ gives us only 80. Is everybody seeing where we're going with that? 400 minus 320, the incremental amount of hamburgers. And then finally the fifth one is just 60. All right. So the next column I want to give you is the average product, which we haven't talked about yet, but we did talk about average total cost. In order to find the average total cost, what did we divide total cost by? By the quantity, whatever they were producing, right? And so a lot of times managers will do something like this. So the average product of labor is simply the total production divided by the number of Russes we're using. No triangles, right? That's the main thing, kind of similar to what we did before, no triangles. And so with the average product, by the way, the marginal product here is kind of undefined because we're starting at 0, so there's no number there. But it's not 0 either. The average product here, we get 0 out of 0 Russes, but 0 divided by 0, that's kind of illegal, so we'll just leave that as undefined too. We get to 1, total production was 100, divided by 1 is 100. So the average per person was 100. What's the average product of producing 220 with 2 Russes? 110. So all we're doing is taking the simple average. So here we've got 3 Russes at the 320 level. So we get 106.67. We'll have a little fraction going on there. And then we get the 4 Russes, we're back to 100, right? So we got 400 divided by 4 gives us the 100. And finally with 5 Russes, we're down to 92. All right, now I want to give you one additional thing of why economics is so important, why college graduates should all have econ class, even though they don't, unfortunately. It makes you a better thinker, a better decision maker. Here's something that you very well could face. I've seen it lots of times. I've had restaurant business. I've had a hotel business, a little small hotel business, like a bed and breakfast business. I've had a horse business with my wife. She's the one who mostly ran that. But I had lots of business experience. And so people do this all the time. Even the highest level CEOs with the MBA behind their name, they'll make this mistake. It's such a common mistake. And it goes something like this. Hey, we're currently making 400 hamburgers, and I just got a new order in. And we need to make another 100 hamburgers, right? What should we do? Well, I know. With 400 hamburgers, we're currently experiencing productivity levels of 100 per worker. So let's just add another worker and we'll make this deal and we'll make a lot of money on this extra order that just came in, right? But what's the problem with that when they look at this number? What are they going to get when they hire the 5th Russ? How many hamburgers are they actually going to get? 92? That would be the average. How much are they? That's not the right answer here.
460.
They're going to get 460. Yeah. They're only going to get 60 hamburgers. And then what's the boss going to do? Russes, what the hell's going on here? You guys are doing 100. You got to work. You've been gabbing. What are you doing, right? Cracking the whip. And the boss is upset, but the boss is an idiot because he looked at the average product, not the marginal product. These Russes were working at max capacity. So what does the extra 5th Russ and the other Russes say? Boss, we only got this size of a grill. I don't want to undercook the hamburgers for our people. and give them poisoning and you get sued, I only have this size of a grill. So when we add that, as Augie said, we started bumping into each other and we weren't as productive as we were before. And that's why we only did 60. See the kind of conflict that comes in when you start to not look at things appropriately with marginal analysis versus looking at the averages. Most CEOs and managers are looking at these averages, not being at least aware that there could be a big difference at the margin, given the constraints of resources. Okay, questions or comments there? All right, that's a good one. Now let's add some dollars into this. Let's assume that we basically got $10 an hour for a 10-hour shift, and I'm going to calculate the kind of the total cost of labor. So I'm going to put a little L here. So we got 10-hour shift, $10 an hour, and so the cost of labor with one Russ is $100. So this is 10 hour at $10 per hour. For, I can pick up as many Russes as I want. Kind of like maybe Ottawa right now. You can hire labor at $10 an hour. You can get as many people as you need at $10 an hour. So that is my total labor cost. Total cost of labor is 100. If I hire 2 Russes, how much is it now? The total cost of labor. 200, right? It's just going to go up by 100 each time. 3 Russes is going to run me $300, 4 Russes $400, and 5 Russes $500. So it's fixed, if you want to look at it that way, fixed per unit anyway. All right. So let's assume some fixed cost. Suppose that grill of ours, or the rent, or however we want to characterize it, is $100. And fixed cost, another thing that you're going to get that we might want to highlight here is there's some amount of fixed cost, and you have to pay your fixed cost even if you produce nothing. That's an important concept, all right? That's what made them fixed, is that you still have to pay your rent even if you don't make any hamburgers. So sometimes on your homework or test, you guys will get numbers, and you remember how you've seen stuff where you fill in the blanks? This is always one that's potentially left blank, because you need to know in the problem, they'll tell you that fixed cost is 100, and then it goes right here, at a quantity of 0, it's 100. What is it at a quantity of 100 with the fixed cost? 100. What is it at 220? 100, 100, 100, 100, right? So it goes down to 100 all the way down. That's the whole idea of fixed costs, is that they remain fixed regardless of the amount of production. All right, so now I'm going to calculate the total cost. And we're just going to assume that this is all my variable cost. So we've got fixed cost and variable cost, and so all of my costs are variable. So my total cost is the sum of those two, right, to get my total cost. So if I produce nothing, I have $100 of total cost. What's my total cost if I produce 100 units? 200, right? We're just adding these across now. 200 plus 100 is 300. And at a quantity of 320, 300 plus 100 is 400, 500, and 600. Okay, so we're getting close. I'm trying to bring in dollars now. That's why we're spending a little time nursing this one out. And so the next column I want to make is the change in total cost. How much is total cost changing by each time we go up? And what's the answer here? As we move through production, what is the change in total cost with hiring additional Russes? 100. So it's going up by 100. Whoops. Here it doesn't go up by, well, it does from 0. Well, no, it's already at 0, so that one's undefined. So 100, 100, 100. So it's 500 minus 400 is all I'm doing here. As I hire more Russes, my total cost is going up by 100 each time. All right. What was that formula? Our last and final column here is marginal cost. What was the formula? That's back in your notes. It's not on the board any longer. What was the formula I gave you just a little while ago on marginal cost? Total cost over quantity? No. Change, and yeah, very important, that change in total cost over the change in quantity. Now the reason I did this for you is we already got this number right here, right? Total cost is not changing. Quantity's got something going on. So what's happening to the incremental cost as I hire more Russes? Does each Russ cost me more? Does each Russ cost me more? Each additional Russ, do I got to pay instead of $10 an hour, $12 an hour or something? No, that's staying the same. So the incremental Russ is always $100 each time I move up. And so for here, the marginal cost of the first hamburger is what?
1.
So we get change in total cost of 100 divided by the change in quantity, which is actually the marginal product, by the way. So the change in quantity here was 100. So each hamburger cost me $1. Is the marginal cost of a hamburger. Now this is where it gets interesting. What's the marginal cost of moving to the next level of production when I hire the second Russ? When I hire the second Russ, what's the change in total cost? It's still 100, so that hasn't changed. But what is my incremental amount of product, the change in quantity? 120. So now this is going to be something less than $1, and it turns out to be 84 cents. So now one hamburger, those extra hamburgers after I hired the second Russ were 84 cents. Why? Because through specialization, 2 Russes turned out to be able to make more than what the first Russ could do. Right? It's kind of our intuition. Now we're translating that into dollars. All right, how about the third one then? When we hire the third Russ, costs go up by 100, but my productivity goes up by another 100. So we get $1 again. All right, now the hamburgers start to get pretty expensive. As we move to the 4th and 5th ones, you're going to start to see some costs changing dramatically because each additional Russ is adding less. But I still have to pay that extra Russ the $100. So the change in total cost from the additional Russ, it was 100, but the extra Russ brought me in 80. And so that ends up being the $1.25. And then lastly, the 5th Russ cost me 100, but that Russ only brought me in 60 more hamburgers. So those extra 60 hamburgers were pretty expensive because I had to spend 100 on an extra Russ, but I only got 60 of them. And so those extra hamburgers ended up being $1.67. All right. So why did this happen? What drove my marginal cost? The reason this is important to look at is that what's driving the incremental cost looking J-shaped. So let's just do a quick little graph here of this. So we're at the quantity here of, I want to go 100, 220, yeah, so 100, 220, 320. So it's not perfectly drawn to scale here, but 400, and then 460. And we have $1, 84 cents, back to $1, back to $1.25, and back to, or now up to 167. And so that is our J-shaped marginal cost curve. It's not immediately obvious to a manager or other people that, oh, well, burger is still $5 a pound, Buns are still $5 a package. Lettuce heads is the same. The tomatoes, my grill I don't even have to pay for because I paid for that a long time ago, right? And so all of these costs seem to be fixed. That's why I like to go through this example. They may not be fixed, by the way, but in this model, I've held all of that stuff fixed, even to the point where I'm adding identical Russes, and we still get a very powerful lesson that your costs are going to go up when you hold fixed some of the other resources. The marginal cost of hamburgers is going up, even though burger prices and all that stuff is fixed, because of the law of diminishing marginal product. All right, so now, as Sam was waiting for, let's define the law of diminishing marginal product.
Yes, sir.
One of the most important things here. So, the law of diminishing marginal product, also sometimes called the law of diminishing returns. Here we go. As you add more and more, of a variable resource, like labor, I'll put in parentheses here, that was my Russes changing. As you add more and more of a variable resource to at least one fixed resource in your production process, to at least one fixed resource, like the grill, which is our piece of capital. As you add more and more of a variable resource to at least one fixed resource, the quantity or product generated by the additional resource, which is the extra Russ, and the product here, of course, was our hamburgers. I want you to be able to read through the general language and kind of tie it back to our example. As you add more and more of a variable resource like labor to at least one fixed resource like the grill, the quantity or product, like hamburger, generated by the additional resource, the additional Russ, eventually falls. Or diminishes. And so that law of diminishing marginal product on our schedule of numbers is this. It might go up originally like we saw with the specialization, right? But eventually it's got to fall. There's no way. If we start, I didn't get too obnoxious with this one because you guys kind of got to the point right away. But what about the 4th Russ, the 5th Russ, the 6th Russ, the 16th Russ, the 33rd Russ? Right? Augie's point of elbowing 33 Russes? Some of those Russes can't even get to the grill at this point. How much extra product is the 33rd Russ adding? Most likely, if they can't touch the grill. Zippo. Yeah. It could go to 0, right? And in fact, in some production processes, it might go negative. Like the extra Russ is a burden to the production process, right? So it could almost go negative. So the law of diminishing marginal product is that concept, and that leads to the law of increasing cost. So what I'll leave you with here that you'll see in some homework or test problems, this law leads to the law of increasing cost, which is the upward sloping marginal cost curve. So sometimes we refer to The law of increasing cost, where does that come from? It comes from the law of diminishing marginal product. So they kind of go hand in hand with each other. Okay, any questions? All right, so we'll pick up there with this material Friday because your test is Thursday. You'll get the whole time during class to work on that test. So I'll be getting the practice test out here shortly. And JC is 4 o'clock in this room for the review session. That's optional. 4 o'clock here with JC. We'll see you Thursday.
Will you be recording that?
What's that?
Will you record that?
I think so. I don't want to, recording if something happens or something, but yeah, we'll plan to try.